Welcome. This is the 2.3 notes. It's called multiplying special cases. We did multiplying polynomials in 2.2, so this is just more multiplying and looking at what the book is calling special cases and just maybe recognizing some patterns that are occurring. Okay. So example 1, just write each product in standard form. You'll see here that for problem A, I have the quantity 5x minus 3 all squared. Whenever I've got an expression squared, okay, so in here I've got an expression, I've got two terms, right, 5x and then minus 3. I need to write that twice and multiply it out. So always, 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 you're going to write it twice and then you'll multiply. Okay. So multiplying, I'm going to distribute the 5x to everything in the second set of parentheses and then the minus 3 to everything in the second set of parentheses. So 5x times 5x, 5 times 5 is 25, x times x is x squared. 5x times minus 3, 5 times negative 3 gives me a minus 15, and then I have an x. Then I'll go through and distribute the minus 3. Make sure you take the sign with you. Minus 3 times 5x gives me a minus 15x. And then minus 3 times negative 3 is a positive 9. Just like before, we always look for combining like terms. So here I've got minus 15x minus 15x. When I combine those, I get minus 30x. And then I'll write down the other terms, 25x squared, the minus 30x, and then the plus 9. There's no more like terms, and this is in standard form because my exponents go from degree 2, 1 to 0. That would be my final answer. Okay. Problem B, much the same. So I'm going to write it twice, always. Have this expression squared. Whenever I have something squared, that just means multiply by itself. And I distribute 3x times 3x. 3 times 3 is 9. X times x is x squared. 3x times 4 gives me a 12x. Then when I distribute the 4, so 4 times 3x gives me 12x. 4 times 4 gives me 16. Look for like terms. Oftentimes when I am multiplying binomials, the like terms are in the middle. This is no exception. It's not always, but that's always the first place that I look because it happens a lot. Okay. And this is going to give me 12x plus 12x is 24x. Right. I have my 9x squared. This is a positive 24x and then a positive 16 at the end. Okay. You might start to notice some patterns as we work through this on how you can kind of think of it like a puzzle on how maybe you could jump from the question to the answer quicker. So there's some patterns happening here that I'd like you to try to recognize. I do want to point out a common error. So I'm going to work that out over here in green. I just want to show you the common wrong way to do it. Okay, so this is happens a lot where students have an expression and they think that they can just square each term. So they can kind of drop this down onto each term instead of multiplying it all out. So they get something that looks like this. They get 3x times 3x, which would be 9x squared, and they get 4 times 4, which is 16. Okay, this is wrong. This is absolutely not correct. Okay. So you can write it down or you can not write it down, depending on how you feel about it. But when I compare the two answers, it's not enough for me to square this term and square this term, I have to write it out because it's an expression. If you don't, you're going to lose this middle term, which is essential to having the right answer. Okay. So every time you see an expression squared, you will always just write it out twice. C is another very similar example. The difference here is I've got two variables. So I have a variable in the first term and in the second term. So let's, just for some practice, see what that looks like. So I have x minus 2y. I'm going to write it twice. So I'm going to distribute the x. X times x is x squared. X times minus 2y is minus 2. So x times minus 2y. So I have minus 2 and then x times y. I always write them in alphabetical order. Okay. Here I've got negative 2y times x. So negative 2 times 1 gives me a negative 2. And then I have y times x. I'm going to write that as x times y because I want to leave it in alphabetical order for consistency. And one more time, negative 2y times negative 2y. Negative 2 times negative 2 is 4. Y times y is y squared. Regardless of if you write this as negative 2xy or negative 2yx, those are like terms. Reminder, like terms are terms with the same variable to the same exponent. So this has an x to the first and a y to the first. Therefore, they are like terms. So I combine these like terms. Minus 2xy's minus 2xy's gives me minus 4xy's. And I'll write down my other terms on the sides. So patterns, patterns, lots of patterns. So far, A, B, and C, this is called the square of sums or the square of differences. So difference meaning subtraction. So A is a square of differences because I'm just squaring something that has a subtraction sign. B is the square of sums because I'm squaring something that has a summation or an addition sign. Those names are not too important, but this one is because this one you're going to hear a lot. D, this is called the difference of squares. We'll work it out and I'll show you why. So it's already written out for me. Go ahead and copy it down. Okay. And I multiply out just like we've been doing. So 5x times 5x is 25x squared. 5x times 3 is 15x. Negative 3 times 5x is minus 15x. Negative 3 times positive 3 is a negative 9. So I go to combine like terms. Plus 15x minus 15x, they cancel. They completely go away. They are opposites. So I'm only left with 25x squared minus 9. All right, so things to notice. This is called the difference of two squares because this first term here is a perfect square and this is a perfect square. If I were to dissect this a little bit, okay, I could rewrite 25x squared minus 9 as a perfect square minus a perfect square. Okay. The square root of 25 is 5. That just means 5 times 5 is 25. The square root of 9 is 3. That just means 3 times 3 is 9. So this is called the difference of squares. The difference of squares in factored form, which is this form up here that the problem was given in, you'll notice that I have different signs, right? I have one subtraction and one addition sign. up here on A, B, and C, when I wrote these out, I always had the same sign. So if we look at A, I have 5x minus 3, 5x minus 3. Because I have the same sign, when I have like terms in here, I just have minus 15x minus 15x. They're the same term. On B, because I had the same signs in 3x plus 4, 3x plus 4, I ended up with 12x and 12x, which gives me 24x. Okay, same thing for C. Now here, D, my signs are different. So let's go ahead and look at E. X minus 7 and x plus 7. I know just by looking at this problem that that middle term is going to cancel because this is the same, almost the same binomial, just with a different sign in between. All right, so watch. X times x is x squared. X times 7 is plus 7x. Negative 7 times x is minus 7x. Negative 7 times positive 7 is a minus 49. So I combine like terms. Plus 7x minus 7x. I didn't change colors partway through this problem, but feel free to do so. And these cancel because they're the exact opposites, and that leaves me with x squared minus 49. Again, if I wanted to, I could kind of pick this x squared minus 49 apart, and I could recognize that x squared is a perfect square and 49 is a perfect square, which is going to lead us into our factoring, which we're getting into later this chapter. Thank you very much, everybody. I hope that came across clearly.